All right, ready to dive into some modal logic.
Always up for a good logic puzzle, especially one with philosophical implications.
Yeah, and today we're using the Stanford Encyclopedia of Philosophy's entry on modal logic.
Sounds dense.
It is a little bit, yeah, but that's what we're here for, to break it down
Right.
and, make it a little more palatable for our listeners.
Absolutely.
And I think especially for philosophers, modal logic is really intriguing
Oh, absolutely.
because it's not just about, is this true or false?
It's about, could it be true?
Right.
Does it have to be true?
Exactly.
And all those kind of in-between shades of gray,
Yeah, exactly.
which philosophers love.
Exactly. So instead of just saying, this apple is red, we can ask,
Could it have been green?
right,
Was it destined to be red?
right, or is it necessarily red?
Yeah, exactly.
And this gets into all sorts of questions about,
Free will and determinism,
Yeah.
like big philosophical questions.
exactly, yeah, could I have chosen differently? All that.
Yeah. Modal logic gives us a nice framework to think about this stuff.
Exactly. And our source has this really handy table that lists all these different
Oh, yeah.
modal logic systems.
Yeah.
And it's kind of like a cheat sheet, I think, for philosophers
Yeah.
to be able to talk about all these different things like necessity.
Possibility, obligation, permission.
Yeah, even temporal stuff.
Yeah, like always will be.
Yeah, exactly. And
Yeah.
we see all these symbols, like a box for necessity, a diamond for possibility.
Right.
And it's really interesting to see how these symbols function sort of like,
Like quantifiers in predicate logic.
Yes,
Like
sir.
for all, or there exists, or for some.
right.
And it makes you think, there's got to be some deeper connection there.
Yeah, there's got to be something going on there. So let's talk about how these modal logic systems are actually built. And our source mentioned this sort of foundational system called K, named after,
Saul Kripke.
Saul Kripke.
Yeah.
So what makes K special?
So case starts with like your basic propositional logic, right? Like with your ands and your ors and your nots.
Right.
But then it adds two key ingredients. One's called the necessitation rule, and the other is the distribution axiom.
Okay, the necessitation rule sounds pretty straightforward. If something is always true, a logical theorem,
Then it's necessarily true.
then it's necessarily true. Like, you can't escape logic.
You can't escape logic? No. It holds in every world.
Yeah, it holds in every possible world.
Every possible world.
Right.
That's kind of the idea. Now, the distribution axiom is maybe a little bit more complicated.
Yeah.
But basically, it governs how necessity interacts with implications.
Okay,
So imagine you have like a necessary implication, like if it's raining, then the ground is wet.
right. Yeah.
Seems pretty solid. So the distribution axiom says, well, if it's necessarily raining, then it's necessarily the case that the ground is wet. So it's like it distributes that necessity through the implication in a certain way.
Okay, so we have this like basic system K, but our source suggests it's kind of bare bones.
Yeah.
It doesn't quite
Doesn't quite get us where we want to be.
doesn't capture all of our intuitions about necessity.
Yeah.
So why do we need more robust systems like,
Like MS4, S5.
yeah, those.
Right. So K kind of gives us this baseline.
Yeah.
But we might want to talk about iterations of modal operators, right?
Okay.
So you might say, is something necessarily necessary
Okay.
or something possibly necessary?
Yeah.
And things like that. So these stronger systems kind of give us the tools to handle those more complex modal claims.
Okay, and for instance, in S5, the source says that possibly necessary is actually just the same.
Necessary.
Necessary. So if something could be necessary, then it already is.
Yeah. It's like saying necessity is absolute in that system. It's like you can't hide from necessity. If it's even possibly necessary, it's just straight up necessary.
Right. Necessity reigns supreme.
Necessity reigns supreme in S5, yeah.
Yeah, and so this raises all sorts of questions like which system best reflects your own understanding of
Yeah.
necessity?
Yeah, which one is the correct one, right?
Yeah, does it depend on what kind of necessity we're talking about?
Yeah, exactly. And those are questions that we're going to have to put a pin in for now and
Yeah.
come back to.
Yeah.
But first, I think we need to talk about
Yeah.
possible worlds,
Yes, possible worlds.
which is where this gets really fun.
Okay, so we'll dive into that next time.
All right, so last time we were talking about all those different systems, like
Yeah, K&M and S4 and S5.
exactly, and how those different systems handle those modal operators like necessarily and possibly.
Right. It was getting pretty abstract, though.
It was, yeah.
Yeah.
So now we got to figure out, like, how do we actually determine
Yeah.
what's necessarily true or what's possible?
Yeah.
And that's where this idea of possible worlds comes in.
Ah, yes. possible worlds.
Every philosopher's favorite.
Exactly. So how do these possible worlds help us make sense of modal logic?
Well, so instead of just having one truth table,
Okay.
we can have like a whole bunch of truth tables.
Okay.
One for each possible world.
Right.
And so then a statement is considered necessarily true if it's true in all of those possible worlds.
Okay.
And it's possible if it's true in at least one of them.
So it's like our truth tables are going multiversal.
They're going multiversal, exactly. And remember how we were talking about that analogy
Yeah.
between the modal operators
Right.
and the quantifiers? So
Right.
like the box symbol for necessarily is like saying for all worlds.
Okay.
And the diamond symbol for possibly is like saying there exists a world or for some world.
Oh, okay. I see.
So there's that connection there.
But wait a minute. Like, not all possible worlds seem equally relevant when we're talking about necessity, right?
Right.
Like, if I say, it is necessary that I finish recording this podcast, I'm probably not thinking about worlds where I suddenly transform into a giant talking frog.
That's a good point. And that brings us to this idea of accessibility relations.
Okay.
So it's not enough to just have like a collection of possible worlds.
Right.
We need to say which worlds are accessible from a given world.
So the accessible worlds are the ones that are relevant to the specific modal claim we're making.
Exactly. Yeah. So the accessibility relation is kind of like this filter.
Okay.
It tells us which possible worlds we need to consider
Okay.
when we're evaluating a modal statement.
So in my podcast example, the worlds where I'm finishing the recording are accessible.
Right.
But the frog transformation world, thankfully, is not.
Thankfully not, yeah. And this accessibility relation can be interpreted in different ways, too.
Okay.
It depends on what kind of modal logic we're using.
Okay.
Like, for instance, in temporal logic, where possible worlds are different points in time,
Okay.
the accessibility relation might be something like earlier than or later than.
So if I were to say, it is necessary that this podcast was recorded,
Right.
the accessible worlds would be all the moments in time leading up to this present moment.
Exactly. So that highlights how, the specific interpretation of the accessibility relation really shapes the meaning of those modal claims.
Okay, so our source mentions how the axioms of a modal logic system, those rules we talked about,
Yeah.
actually, they reveal something about the properties of this accessibility relation.
That's right. We can think of the axioms as like clues
Okay.
that tell us about the deeper structure of possibility itself.
Right.
And this is where this idea of frame validity comes in.
Frame validity, remind me what that is again.
So an axiom is frame valid if it's true in every world of any model
Okay.
that's built upon a frame with a certain property.
Okay.
So it's kind of connecting the logic
Okay.
to the structure of possibility.
Can you give me a concrete example of how this works?
Sure. So consider the axiom, box A, arrow A, which basically says whatever's necessary is also true.
Okay.
So that axiom corresponds to the property of reflexivity
Reflexivity, okay.
in the accessibility relation.
Eating.
So a relation is reflexive if every element is related to itself.
Okay.
So in this case, it means that every possible world can access itself.
Okay.
And so if a world can access itself,
Yeah.
then whatever is true in all accessible worlds
Right.
must also be true in that world itself.
Oh, okay. So by understanding frame validity,
Yeah.
we're basically decoding this hidden blueprint of possibility.
That's a great way to put it, yeah.
My brain's starting to hurt a little bit.
I know.
We've covered so much, from the basic systems to possible worlds to accessibility relations.
It's a lot.
And now frame validity.
Yep. But before we give your brain a break,
Yeah.
there's one more area we got to explore.
Okay.
Quantified modal logic.
Quantified modal logic. That sounds like we're about to ramp up the complexity.
We are, yeah. But this is where it gets really interesting for philosophers especially, because now we're going to start thinking about existence across possible worlds.
All right, so we're back, ready to tackle this quantified modal logic.
Yeah, this is where things get really meta.
Yeah, so last time we were talking about possible worlds
Right.
and how they relate to each other.
Accessibility and all that.
Exactly, but
Yeah.
now we're bringing in quantifiers,
Yeah.
right? Like for all, and there exists.
Exactly. So we're not just talking about propositions anymore. We're talking about
Yeah.
the things those propositions are about.
Right, so who or what exists in these possible worlds?
Yeah, and that raises some really interesting questions. Like, for instance,
Yeah.
do all possible objects exist in all possible worlds?
Okay, so like every conceivable thing
Yeah.
just exists no matter how weird it is.
That's one approach. Yeah, that's called the fixed domain approach.
Yeah.
It's
Well,
like everything's just out there somewhere.
I mean, it has a certain simplicity to it, right?
Yeah. It does, yeah, and it lets us kind of stick with the familiar rules of classical logic.
But it doesn't really seem right, does it? Like, I mean, is
Yeah.
this coffee cup really necessary?
Yeah, that's a good point. And that brings us to the alternative, the
Okay.
world relative approach,
Okay.
which says each world gets to decide what exists in it.
Okay, so like in some worlds, this coffee cup is here,
Mm.
and in others,
Poof.
gone. It doesn't exist.
Yeah.
But doesn't that mess with our logic a little bit?
It does. It does, yeah, because in classical logic, we assume if we can talk about something, it exists.
Right.
But if domains are world relative,
Yeah.
some terms might not actually refer to anything in certain worlds.
Oh, so we might need to like rethink how quantifiers work.
Exactly, yeah. And our source mentions a few ways to do that.
Go.
One option is to switch to what's called free logic,
Free logic, okay.
which can handle those cases where terms don't actually refer to anything.
So it lets us talk about things that might exist in some worlds, but not others,
Yeah, without breaking logic completely.
without everything falling apart.
Exactly. Another option is to keep classical logic,
Okay.
but make some adjustments to how we interpret things.
All right.
Like maybe we designate a specific actual world
Okay.
where all our terms get their primary reference.
So kind of anchoring our language in a specific world
Yeah, and then we can still talk about those other possible worlds.
where things might be different.
Exactly.
So as you can see, quantified modal logic gets pretty deep.
It does. It gets into these really fundamental questions
Yeah.
about what exists and how we can even talk about existence.
Well, I think we've given our listeners a lot to chew on today.
Yeah, we've gone from the basics of modal logic
Possible world.
to the very nature of existence.
And I think it's safe to say
Yeah,
that our exploration of modal logic has only just begun.
there's so much more out there to explore.
But for now,
Yeah,
we'll leave it there.
we'll let everyone's brains rest.
Yeah, thanks for joining us on this deep dive into modal logic.
It's been a pleasure.
And we'll see you next time.